Hello and welcome to Algebra 2 tutorial. In this video we're going to start a journey to solve quadratic equations. It's going to take us a couple videos because there are four main ways to solve a quadratic equation. There is solving it with square roots, by factoring, completing the square, and the quadratic formula. We can't do all of them, we're just going to mainly focus on square roots in this video. But first, what does it mean to solve a quadratic equation? Well, a quadratic equation is a parabola, and if you get a visual or a graph, you get something that looks like that. And the solutions to a quadratic equation are the x-intercepts. Those are usually what you are interested in. And we've got four vocabulary words that describe the same thing. So x-intercepts is one. So right here you have one, and right here you have one. But those same 2 points are also called the solutions. They're called the zeros, and they are called the roots. Now, why do they have those names? Well, think about this point right here. That is the point -8, 0. And this point over here, that's roughly what, -1.3, 0 as well. As you can see, the one thing they have in common is the y value is 0, which is why they are called zeros. They're called solutions because they are going to be the answer to equations that we solve. So that one makes perfect sense. Hopefully x-intercepts, that's where you cross the x-axis. That also makes perfect sense. The only weird one is this word root that you have to remember. I don't have a good reason why it's called root. Try Googling it, maybe you'll find something. But those four vocabulary words are all pointing towards the same thing in a quadratic equation. So, let's go on to our first method here. We are going to solve a quadratic equation using square roots. So here we have two nice easy examples. Square roots is definitely the easiest one. We just need to get x by itself, and because there's only a squared term, this is pretty easy. To get x by itself, you divide both sides by 5 in this case. You have x squared is equal to 55 divided by 5 is 11. And then we need to get the x by itself, so we have to get rid of the squared, and the opposite of a square is a square root. So we square root both sides. That goes away, and you are left with x is equal to, and the square root of 11, you can just leave it as the square root of 11, or if you actually want a number, let's get a number. So we need the square root of 11. Oh, it didn't give me the exact answer there. .31. Now, here is the tricky part about this. That is not our only answer. In this case, it could also be -3.31, because anytime you cancel out a square with a square root, you should get two answers. One of them is positive and one of them is negative. Think about it real quick. If we take 3.31 and square it, we'll get 11. If we take -3.31 and square it, it's still going to be 11 because the negative times negative, when you square it, will turn to positive, and you'll again get positive 11. So we have two solutions here. You got to make sure that whenever you do this step right here, you square root a square, that you have a positive answer and a negative answer. All right, next example. It looks a little different, but it will be the same. Now we have an equation with a y. Well, think about that. That's still going to give us some sort of parabola, and it will hopefully cross the x-axis somewhere. And what else would we call these 2 points? Zeros, because the y value is 0. And so we put in 0 for y. That will give us our x-intercepts. And so now we have an equation that looks very similar to the previous one that we can solve. So we'll add 64 to both sides. That goes away. Divide by 4 on both sides. So we'll get x squared is equal to 4 goes into 6 2 times with 2 remainders. 4 goes into 24 6 times. So we have x squared is equal to 26. And again, we're going to square root both sides. And here we're having that weird thing happen. When those cancel out, we have two answers now. X is equal to, one of them is positive, and one of them must be negative. And you can write it like that for simplicity. That way you only have one math statement to write down. And so we need the square root of 26. Oops, not 266. It is 5.09, so let's round that up to 5.1, I suppose. And that is positive or negative in that case. So hopefully that looks exactly like solving any other equation. You just have one extra step of square rooting both sides. Let's take a look at a word problem for an application. So quadratics are often used for projectile motion. And so here a ball is being dropped from a height of 200 feet. We can model the position, or in this case the height of the ball, using a quadratic equation. So there they give us the quadratic equation. When will the ball hit the ground? So let's first draw a quick picture of this. So we have a ball that's up really high. So it's going to start up here on our y-axis. And then it drops down. And it hits there. And we've got the height along the way. So when will the ball hit the ground over here? Some time t. So it's up here at 200. If I want to know when it hits the ground, well, the height will be 0. And so we're going to take this h of t right here, and that is going to become 0. Because when we hit the ground, our height is 0. Again, that's where the vocabulary word 0 comes from. That gives you your x-intercept. So let's see. To solve this, we got to subtract 200 to the other side. So there is negative 200 on that side, negative 16t squared. We need to divide both sides by negative 16. So I know this answer will be positive, but what is 200 divided by 16? Let's get a decimal answer here. 12.5 it looks like. And then we have to square root both sides. Now remember, this does mean our answer will be positive or negative. So what is the square root of 12.5? Square root. Why am I? There it is. 12.5. 3.53. Squeeze it all in there. There we go. And the answer is positive or negative, mathematically. But of course, if we're dealing with time, hopefully we can realize that negative time doesn't really make sense. Yes, this parabola does go the other direction, but that doesn't really make sense in real life. And so, because that's not part of our domain, technically, the time it hits the ground is positive 3.53 seconds. Mathematically, there are two answers, but realistically, for this modeling problem, there is only one. All right, there was one more question here. When is the ball 50 feet above the ground? Well, so we don't want to go all the way down to 0. We want to come over here to 50. So where is this ball only 50 feet above the ground? Well, that means the y value is 50, not 0. And so we would solve this equation, negative 16t squared plus 200. But I'm hoping you can see that's going to be the exact same process. We're going to subtract 200, divide by negative 16, and then square root both sides to get our number. The steps will look exactly the same. The number should be different, though it's not going to be the same. But I don't think you need me to do that one. You can finish that if you like. For now, I'm going to give you some other practice problems to look at, because I think we're doing pretty well on this. So let's recap real quick. We are solving quadratic equations. Now, there are 4 methods for this, but we have only looked at one, solving with square roots. So here are a few practice problems for you. Good luck.